Think about how financial systems have worked for centuries. If you want to transfer funds or record a transaction, you rely on a single central authority, like a bank or a clearinghouse, to verify the math and approve the exchange. Blockchain technology wipes that central office entirely off the map. There is no vault, no CEO, and no central server sitting in a heavily guarded building making sure the numbers add up. But removing that authority creates an immediate vulnerability. Without a central boss checking the math, a user could theoretically try to spend the same money twice, invent fake transactions, or simply rewrite the historical ledger to make themselves rich. To fix this, the system replaces the corporate office with an army of scattered independent witnesses. Thousands of individual watchdogs are deployed to constantly monitor the exact same network. By tearing down the central point of control, the network creates a vacuum, and it fills that vacuum with a system of continuous, decentralized observation. Those scattered witnesses are called nodes. They are simply thousands of independent computers distributed across the globe, each one running the exact same blockchain software. Every time a new transaction occurs, these computers spring into action. They watch the exchange, check the data to verify its legitimacy, and then quietly write down their own individual record of what just happened. Because the workload is distributed so widely, the network is resilient. If one single computer loses power, or 100 machines go offline simultaneously, the entire system doesn't even blink. The network survives because it doesn't rely on the strength or uptime of any specific machine. It functions through redundancy. Thousands of participants constantly backing each other up by doing the exact same job. The most vital are full nodes. They download and store the complete blockchain history, stretching all the way back to the first Genesis block. They operate on zero trust. A full node refuses to take another computer's word, independently checking incoming data against its local copy. Taking on that job comes with a physical cost. Running a full node requires significant computing power and massive amounts of hard drive space just to hold that ever-growing ledger. Despite the cost, these massive ledgers provide the foundation for the network. Because they refuse to trust outside information, they ensure the historical record remains accurate. On the other end, we have light nodes. Instead of the complete history, they take a technical shortcut. They function by skimming just the block headers, tiny summaries of each block, providing enough information to verify a transfer without holding the heavy data underneath. If you have a cryptocurrency wallet installed on your mobile phone right now, you are likely carrying around a light node. The trade-off is practical. Light nodes operate with speed and use almost zero storage space on your device. But when they need to reference the deep historical picture to verify something complex, they have to ask a full node to provide the complete data. It is a symbiotic division of labor. The heavy full nodes guarantee network security, while the light nodes provide the usability required for daily life. All of this brings us to a synchronization problem. If thousands of scattered computers are constantly checking their own independent ledgers, how do they actually agree on a single truth without a leader to call a vote? The answer is consensus. Consensus is a set of mathematical rules hard-coded directly into the software that every honest node follows. Picture a vast classroom where the teacher asks a complex mathematical question. Instead of one student raising a hand, every single student independently calculates the math and simultaneously writes down their own answer on a piece of paper. If the vast majority independently reach the exact same mathematical conclusion, that shared answer is accepted and permanently codified as the official truth. Now, suppose one bad actor tries to submit a fraudulent block. They attempt to sneak in invalid transactions or alter a past record to steal funds. The system defends itself automatically. Because that fake block fails to match the historical record held by the honest majority, it is instantly rejected as a lie. Trust becomes a byproduct of the math itself. It is a system distributed across the globe, secured by the logic of consensus.